So now we have the idea of the isoquant. An isoquant is a graphical depiction that's quite useful. Iso in Greek means equal, so isoquant means equals quant, right? So what are the combinations of labor and capital such that we get the same amount of output? That's what an isoquant is. So just think same quantity is for one curve of the isoquant. If we change quantities, we need another curve, right? So that's what we're going to do. Let's look at the representation of this in a graph. If we have labor on the horizontal axis against capital, we'll see this is the curve. And this is an isoquant. The quant being 100, and these are all combinations of labor and capital that will get us exactly the same place. It gets us to 100 units of labor. And we can substitute A for B, and we wouldn't really do much in terms of our output. In fact, we get the same, by definition, the same number of units. We'll see later on that the costs are different at points A and B, but for now we're just looking at combinations to achieve a certain output, in which case we're indifferent. Then we notice that the isoquant moves outward from 100 to 200, 300, and these waves just move out further and further because we're now using more of labor and capital, and that should get us more output, which it does. So that's what an isoquant or a set of isoquants look like for a given manufacturing process. What is the marginal rate of technical substitution? That's a fancy sounding term to say if we're on a point on the isoquant and we move a little bit one way or the other, how much would change if we did that change, right? That's a marginal. That's what it means. That's what's that next movement going to get us. And this is represented by the slope. Once again, the slope of the isoquant is the marginal rate of technical substitution. As we go from one to the other, the margin or slope is this rate that we're looking for. So let's see how this works on the graph. So we start with what we've seen before, but let's move now 1 unit to the left of where we were at point A, and what happens to B. All right, so now we see that as we kind of walk on this curve from here left 1 unit on the labor dimension, we end up here on B, which shows this amount of change in the capital. That gives us a slope. So the change in the capital, which is rise, divided by the change in the labor side, which is the run, is -1 here gets us to 1 plus here. So here the rate is -1, marginal rate of substitution, technical substitution for capital and labor. So let's see what happens when we make another change at a different part of the curve. So let's say we're at C and we want to move 1 unit to the left from C. So here, 1 unit to the left from C gets us over to point D, right? So this move has the slope that is different. The slope is 3 divided by -1, because as we go down a -1 on the labor side, we go up 3 on the capital side. So 3 divided by 1 with a minus sign. So it's a -3 as the rate of technical substitution. So we can see that at different points of this isoquant, we will see different rates of change. And we saw this before when we were looking at even a straight line. But here it's even more pronounced because we're on this curve.